Okay. Well, I think we're going to go ahead and start. If you don't mind, I'd rather sit than stand. And we're at the same level here. We can do that. So what I've got is I have a PowerPoint. It's not very long. It's about 5 or 10 slides. We'll go through it, explain what we're looking at, and then I'm going to switch and show you a demo of the output of that. I'm sorry? Oh,
Sector 7 is very high risk.
and here we go. This is the 12 o'clock. Boom. Okay. Everybody's logging on. Firefly. Okay. So, oh, I see, bastards. So that's what we're looking at doing is documenting the application software that you have.
In multiple languages.
Oh, this doesn't work. All right. This doesn't work. Okay. So what we're going to be discussing here is we use Doxygen to do this. Okay. So we're going to talk about what Doxygen is. And then what we're going to mention after that is what LegacyMap brings to Doxygen to do that. And then what languages do we support currently? And some of the future languages that we're looking at putting in there. And then we'll show you some examples, and that will be the demo. Okay. Did we not go through Doxygen? Okay. Well, Doxygen is actually freeware. It's been around for maybe 20 years. And what it does is it reads through all of your code, which is really C code and Python and Java and things like that. And it just goes through it all, it documents everything, links everything together, shows you where all the dependencies are, where the parameters that go back and forth between various procedure calls and things like that. So it really connects everything, and then it produces output, graphical output.
And HTML.
In HTML, that's correct. So you can fill up an entire website with all of your information. It's very useful for modern languages. For COBOL, it doesn't know anything about COBOL whatsoever. COBOL is totally unknown to it. Fortran has a lot of difficulties. Marginal. So we did some stuff to make it work. COBOL, Fortran, we can do basic also, though we haven't done it yet because nobody's asked.
We have. No, we did a I did the
Did
basic
we?
one.
Okay, very good. Basic. And then Pascal, we would go and put that in there, and any other language that would come up. So what we do with LegacyMap is that it's a front-end parser. So we read the code, the OpenVMS COBOL, we read the code, and we create an environment out of that code for each file that contains all the information that Doxygen needs to know what to do, or how to document, how to relate those files together.
We make a meta C language out of COBOL. Calls in, calls out in a language that Doxygen understands.
So we convert the OpenVMS 3GL into a form that's usable by Doxygen. So at that point, we sort of fake it out and put in all the tags and the meta tags and everything in there so that Doxygen knows what to do with that. Right now, we support VMS, Fortran, and 77 and 90, VMS, COBOL, Basic, and all of these ones. Yeah, all of them. Now, of course, VMS has its own extensions, so we have to declare those and make them understood by Doxygen. Okay. Now we talk about Doxygen. I guess I got it in the wrong order. Okay. So it's free. It's open source documentation generator tool. It's there. You can download it. You can install it. I don't know that it's going to install on BMS, but it'll install nicely on Linux and other places.
John Reagan made a version for VMS, but it's not out of the box.
Yeah. So what it wants is it extracts the information from the formatted comments and source code. And then you can actually go in your source code and add extra tags in there to tell Doxygen that you really want to look at this specific item in a specific manner. We'll talk about that later. It creates the dynamic call graphs, and we will see that in a little bit. But it also creates a use repository of your source code. So if you wanted to say something like, I would like to know which program calls this procedure, you can do that. Okay, you can say this procedure, who calls it? So you get the list of all these things.
Called by that procedure.
And the other way around, you get it both ways. It creates everything into HTML, but it also does it in a PDF, though I've never seen it, and it's kind of useless to have it in a PDF format. But it would be good if you wanted to have references, lists of items or lists of programs or lists of procedures that you can do something, you can get it in PDF. It supports these languages that you saw there, but it has to be ANSI Fortran. And guess what? OpenVMS Fortran is not ANSI Fortran. Okay.
And it doesn't do Fortran 77, which is a big problem because very few people have Fortran 90.
So it runs on Linux, Unix, Mac OS, and Windows. And you said VMS, but I've seen it.
By John Reagan, but.
So what some of the features in there is that it generates these cross-reference documentations. This is what I was talking about. Program A calling procedure B and so on, and connected back and forth, and all of the dependencies for there. It'll support diagrams, and it creates class hierarchies, and it uses GraphViz to produce these graphics that we'll see in a minute. You can actually, that's what I was talking about earlier, Markdown integration. You can actually put some more tags in your code so that Doxygen can pick those up and record that and create a special section to be able to trace that later on. And it provides, that's what I do for the databases. Okay.
We'll see that.
Yeah. And yeah. And then it provides a static analysis for the code base, so you can see all these references. And it's to visualize your program or your executables and all the dependencies that are going in there.
Which we will see in a second.
Okay, what we do with LegacyMap is that we take care of these things and we extend it for the languages that we saw earlier, but we also go one step beyond that because a lot of people have RDB or Oracle or Postgres calls and stuff like that. We've extended the program or the extraction of the data, if you will, to get the database names and the tables that are associated with each database to be able to be listed as separate entities inside of the code, inside of the output. And then we are able to show you the programs that access a table, the programs that delete from a table, the programs that insert into a table, and the programs that update tables, okay? By table, and then of course by database, because RDB users like to have multiple databases in their applications. Oracle users and Postgres users will have a single database, usually with lots and lots of tables in it, schemas. We also can do the file access, RMS file access, the ones that open, read, write, and delete, okay? And we also do for COBOL. Who uses COBOL here? Okay. What do you guys use? Pascal? Ooh, he loves Pascal.
Translator. Let's talk later.
And how about you? No. Okay. So anyways, for COBOL, what we found is to be able to track the O1 level items, where they're used and where they're defined, especially across copylibs and things like that, and to be able to say, if I touch this copylib here, which other programs are going to be affected by that? Okay, so you have that reference in there. And then, of course, we can extend it to other levels. These things are extensible. You can add whatever features you want in there to be able to get it. Now that we have the framework to be able to do the extraction, it's just a matter of looking for certain constructs and tagging them. Okay. And that's why I said we do the copybooks and the includes. For our COBOL folks. Okay. We do COBOL, the PCOs and the SEOs, whichever way you want to call it. We identify and mark up the calls and the procedure calls, and then the parameters that you're passing to them. The file access, as I talked earlier, open, close, read, write, the 0, 1, and so on and so forth. The PCOs, we go beyond that. We will actually read what's in the exec SQL begin and exec. We will parse that, and we will look for the tables that are used in there and the access that you're doing to that table. Okay. And then we do that also and also beyond that, actually this is for any one of them, but we do the extraction of the schemas and load up Doxygen with that. So you don't have to do that and declare it to Doxygen. We take care of that, going out to read your database, pull out the schemas, pull out all the tables, and prepare everything for you. Okay, it's all out of magic. So at this point, we get more into visual stuff because we are going to see this on the graph and we want to be able to pick out things. So what we started doing is that when you have multiple databases, such as in RDB, what you do is you declare each database name and you give it a color. It's a little file that's on there, so you can specify the color that you want for each database. And then at that point, what happens is when we generate the output and you see the screenshots and everything, the database A will have blue, database B will be yellow and everything. So you'll be able to pick out immediately which color or which database is being accessed. We also went one step further.
Let me tell you, we have most of our main developers are colorblind. So when they put out their colors, it becomes a little interesting. Magenta on right percent.
We've had some fun ones.
We had some fun with colors.
So I'm sorry, I'm a pro-tan, you know. What we also do is each of the table, we keep track of the schema of the table, the columns. We know what's in the column on each of them. Right now, we do not do, oh, this is a select and you're asking for this column, or this is an update and you're updating this column. We could do that because we have the information, but we're not doing it at the moment. Okay, this is getting too granular.
It would make the graph.
We think, yeah, it would be crazy, but you could actually do specific areas because the information is there. You could extract it and get it. Okay. What we also do is we give a shape to the box that contains the database name and the access type, the database name, the table name, and the access type. We give it a shape so you can see which, the select looks like this. The fetch is triangular like that. You'll see that. And then deletes are very specific, so you can visually identify rapidly, you know, who's doing what to whom, just by looking at it.
Which we just said all this.
I think I've already covered all this. Yeah. Yeah, that's it. That's just what I'm saying. I'm talking faster than I can read, but those are all the items there. So in your notes, you'll have all that information. Okay, so in Doxygen functions, what we do is for each table in each database, we create a specific access, a specific function. So there'll be database A, table A, underscore select, underscore delete, underscore update, underscore fetch, fetch, and underscore insert. Okay, So in this way, if you can see visually where everything is, but you can also go to that specific call and you want to say, I want to know for this table in this database, who does an access to update that table.
Program, and that's executable systems wide.
Yeah, and that'll go across your entire code base and come back. These are the modules, and these modules are connected to these executables. Exactly. So you'll find out exactly who's doing it.
Very useful.
So this is very important when you're doing management of a database and you're trying to do something to it, and you want to know who is deleting records in my database. You can find out which programs do that. Very good. Yes.
Very real world situation.
Mhm.
Very.
One of the things we often have to do is error happens. Someone deleted a record. Then you've got to find out, was it a person or was it a program? If it was a program, which ones could have?
Yeah.
Yeah.
And reading through all the source code from modules 20 years ago, where it's something like this.
Crazy. Yeah.
Click on that.
Hey.
Well, it could have been these programs, then I can see where they're invoked.
As you say, it is incredibly useful. I mean, obviously, we use this when doing a migration. We use this to step so we can see everything that's going on. And then somebody thought, oh, maybe other people would like this, which is why LegacyMap got born. Really.
Yeah, absolutely.
We've had this for years. We just never made it public.
Okay, so call graph examples here. Oh, this is where I discussed it.
Colors, light green or white.
Yeah. Coded by database access, and then select as a folder, fetch as a tab. So,
Got it.
triple octagon and a house and an octagon and things like that. So we'll see that. Here's an example in here. So I'm looking here. This program is the main program. It calls and it accesses, it does select on the main DB and account properties. And it also, this is another database, different color, and it does select on that one. On this one here, are you seeing my?
No, not
Oh, no, not at the mouse. Oh, wrong mouse. This one here, this is another database, and I do an insert in this one here. And this one is a delete, okay. And this one is a select, and so on. Okay, different databases, different tables, and the action that you're doing to
And
it.
you can also see that if account master had called calls those subroutines, get ATB master, cache items, even down to the level where it calls sys.fao, which we see as an external function rather than a VMS block. So
Correct. So in this case, your account master is calling checks daily adjustment that does transaction properties that actually touches this database here, does an insert here, a delete there, and an update. Okay. But if it goes through this procedure, well, we won't see it here, but it goes down to here. So you're able to follow it. But again, this is graphical. You can see it, but you can also get it in tables. So you can get all the listing and be able to use it to do something.
And everything is hyperlinked. So even though you don't see it, you will see it in the next one. You can click on any of these things and see who calls me. So it's complete. The whole thing is hyperlinked.
Yeah.
I'd like to claim credit for that. That was just Doxygen.
That's fine.
You just process it into a form. Oh, there we go.
Yeah. So this is a bigger one, if you will. This one doesn't have any database access, but it has
Pascal runtime.
procedure.
Did this on the Pascal or C++ runtime. that was handy. We didn't
Yeah.
do it.
That's right. That is Pascal. Yeah. Okay. Okay, that's it. So I'm going to stop sharing here.
Now we get to the. So saying you can't, so they won't be able to see it on the presentation.
Can you see this?
Yeah. We also got this big shared content.
I know, I'm trying to get rid of that. Like that. Oh, no. What is, oh. It's on this one. Hang on.
Oh, and you know what? We got, okay, it doesn't recording anymore. It's good enough.
Yeah, it is recording. I'm trying to make it maximum. I'm sorry, what now?
Feel free to take over.
Yeah.
1 second.
Please.
Despicable challenge.
Like that. This
Thank
is
you.
the biggest we can do.
Okay. Yeah. Is it? Yeah, I guess it is the biggest. Yeah, that's going to be a problem. Okay. Well, we'll deal with it. Okay. So, right now we arrange this. We have different topics. We also do SQLMOD procedures. That was one of the things that was mentioned in another previous talk. SQLMODs are procedures that are built for RDB. So our tool will go in and read the SQLMOD procedures, document them, and store the database and the table and everything that they're accessing. So you'll get that.
They're seen as subroutines. I mean, it's
Yeah, they're all subroutines at this point. Yeah.
Subroutines.
But we take care of SQLMOD. So that's another language, if you will, that we have in there. And then if we look at it, I'm sorry here, this is real data, real customer code. So I have to obfuscate it. That's why the words look like crap, because they're logically connected, but they're meaningless. But this is an actual application from a customer. So they've got some SQL procedures here, SQLMODs.
We can click into those.
Should be able to. And then it shows you what table is being used. Okay.
This is very cool.
And then we have the database tables. These are all the tables that are out there. And as I was saying, like local DB, this table, this date, the table, you got the delete, the fetch, the insert, the select.
What happens if we click on?
And if we click on one of them, these are all that's the structure that's in here. Hang on, this is a little slow. Oh, it's because that one's not used. And this program was a proof of concept, if you will. So the table, we've got 10 different databases and hundreds of tables. These ones, this one's not being used. I'd have to figure out which one is. It would show back to who's using it, except that we didn't document everything. So we've got the database is completely documented, but we only have a partial of the source itself. So it's only accessing a few tables, and I'm not sure which one they are.
You do a source. Let's go to the source code, COBOL source code.
No. I do not want to expose. Oh, sir. Okay, it's coming. This is actually HTTP. It's a website, so it takes time to populate. Sometime it's coming in from Austin. It has to stop at the border, I guess. Looking here. Yeah, they're just not being used. Okay. Let's go to, if I look at files. In Cobb New, this is what we're going to see. PCO. PCO files are the ones that have access to the database. And here we are. Okay. Now, because the screen is small and the graph is really big, I have a problem. I would have to make it really small to be able to see it.
Well, we'll certainly show what we're seeing here. We've got the main level and
okay, but that you see it, but it's very small. So
this is a COBOL function, right?
Yeah, it's a COBOL program with functions. So here,
This is so cool.
this takes you back to the procedure that actually calls it. So you've got all that information
Yeah,
here.
I can stop a bit on that previous one. It was kind of cool.
This one?
The one that had all the squigglers and yeah, just explain a bit about what's going on.
So this is the main program down here. Okay. And these are all the procedures that are built into that program. And there are procedures that call procedures that call procedures. Okay. And some procedures that call procedures that access the database in that level, or they will access it at another level. But you've got all the information there on that one. So this is one single program. And I think it had 80 procedures that were built into it, or 80 dependencies inside of it. And you're seeing it right here. This is what it's all
So
about.
this is program A calling subroutine B, C, D, E.
And this is only half. I can't see the bottom because the screen is too small. But you have all the whole thing. If you print it out, you have all the information there. It's very good. Or you can go to a specific procedure. Let's see, let's take this one here. And that one will talk to you about, these are the things that I'm accessing. Okay. And then it's got another one. So we can go to further and there's another one. So everything is there, the link up and down.
So in terms of COBOL, we process the COBOL now because Doxygen's only going to understand C. We take all the calls, turn them into a meta C version that ultimately Doxygen can understand. Which is why you don't see a lot of we do actually then document COBOL code in there, but it's not like it would be for Pascal. For Pascal, we actually turn it into C++. So you see all of your code, all of the Pascal code in C++. And it looks almost identical, which is nice. So there you get to see all of the code.
Yeah.
Not just an abbreviation of the calls in and the calls out.
And in this case, we also, for the COBOL, we keep, like as John says, we keep the code, but we keep all of it, including the comments and everything, so that when you click on a file, you see it. But I'm not going to do it here because I strip out all the comments when I obfuscate because it's got customer information and names on there. And I don't want to even go there.
Just to be clear, we
Okay.
got permission.
Yeah. I'm sorry? Oh yeah, you can have a source code in there, and actually it's all in there, including the comments and everything. And it also tells you where the things are. Like this procedure, you're calling it at line 2421. You can go there. So you've got all that information. As we expand on the capabilities of what we do for COBOL, we can start also keeping track of where the O1 levels are used inside of your code, which makes it very interesting. We are afraid to go beyond O1 levels because you can really go crazy, but if it would be possible to do it. So the capabilities are there to do that. We know how to do it. We have the technology, we've got the framework, we know how to run Doxygen to make it work for us, and we can go crazy. But COBOL, with all the levels, you can go nuts. So this one didn't have any files, so they didn't use any file. Everything was database. Okay, but if we had files, then there would be a listing of all the files, and then we could click on a file and see who's using it. Yeah. But in this section of the demo or the proof of concept, there were no files.
And obviously, as Jenny said, we don't put the COBOL in there because it's customers COBOL. But this is actual real.
This is an application. This is a real application. We transferred it from OpenVMS to Linux and made it run. And then we take we can take the code from OpenVMS or the code that was migrated to Linux. You can do either one to do this. Okay, so it doesn't have to be migrated.
Yeah, forgetting migration. It just so happens this is a tool we use.
Yeah.
But it just became really useful to
find out where everything was.
To be able to tell who did the delete? Where is that delete?
So that's
you're searching and
so that's why we made sure that it would work on OpenVMS code untouched as is, with RDB. right there, or Oracle for those that use Oracle directly. So it will work just the same way.
And for RDB, the SQLMODs also process, which is really
Yeah,
nice.
the SQLMODs, absolutely. Okay. Absolutely.
Two parts of the same question. In our environment.
Well, that'd be interesting.
Also, before even leaving that, the CDF files and all the other files, we could do those.
Well, actually, we do those.
Yeah.
So I actually wrote a translator to take ACMS and turn it to Tuxedo, and that includes processing the TDS, the GDS, and the menu files. So in this case, I turned that into C++, the TDFs and the GDFs, which of course Doxygen handles beautifully.
Yeah.
So, yes.
Right.
So it tells you where all these.
So yeah, the TDFs, I do translate the TDFs to C++.
There's a DCL.
Yeah.
Yeah.
Yeah. But the thing is, we could even take it directly from
Well,
VMS.
we
Okay.
did. I mean, we
So, but the other thing is just the same way as we did the databases. I mean, Doxygen knows nothing of databases. It's a concept that is remote to it. But what we did is we created an environment that says these are databases, and this is the relationship and how they connect together. And then so we could do the same thing with anything that you've got, including DCL.
Well,
Yeah.
let's step back a little bit here. The DCL thing.
Yeah.
Yeah, we could certainly, if we knew exactly what you wanted, we could certainly scan the DCL.
I'm not thinking of the detail. It's just.
I know, but we could certainly scan the DCL. What we have to do to make it go through Doxygen is create anything into a C environment. So a C meta language, and we could certainly do that. We could certainly scan through DCL looking for procedures, looking for forms.
We have DCL that holds lots of different COBOL, multiple wheels, shelves.
Okay.
With the $5 form.
Yeah.
We could certainly do, yeah.
Oh, absolutely. That
we
we
can
can
do
pick up. We can pick that up easy. That's not a problem. And
I
you create a.
I wouldn't say it's going to be that easy.
Yeah. Oh no, come on. We create a meta tag for that.
Who's
Okay.
That'd be me.
No, I'm the one that did this for Oracle for the databases. Okay.
DCL.
So we're talking the same thing here. No, I'm talking, it doesn't matter because all I need to do is look for the word, or even in the COBOL, see where you're doing the spawn, lid dollar spawn or whatever. I meta tag that and say, this is something that I want to decipher and understand and point to the DCL file that you want. Exactly.
If the name in the spawn is a recognizable name.
I totally get that.
If it's going to be disk plus device plus name, that gets a little trickier.
But then I would meta tag that so you could see that's the construct that you're using.
So
There are many ways of solving this.
The $5 do command, if it's got something that's recognizable as being the name of DCL script, and it normally is.
Yeah, so the path to DCL is all.
Yeah. We can do something, we can get something there. And yeah.
Absolutely. As long as we understand what it is and being able to decipher it and to figure it out, then we meta tag it.
Without that part,
yeah. No, you're right. Ignore him. It can be this easy. It's DCL. There's nothing that easy about DCL. But yeah, it can. certainly
The concept.
the DCL calling programs with a run exec, yeah, you add symbols to that. If the symbol is a run, then it's up. But then oftentimes people use the same symbols to do the same runs.
Mm.
So it can be special cased. Yeah. But something to look at. Something to look at.
And in Pascal,
I guess you're not using databases, right? Using RMS files. You guys in Canada? Okay, so we know the application we're talking about. Okay, as you know, we can convert that to C++.
Yeah.
If nothing else, if we go no further, you'll see all of the code. It's cool, but it does mean doing the C++ translation first, which should be pretty easy, and then it'll just get them into here in this format.
and if they use files and things like that, we can meta tag the files.
We know who these guys
Oh, I know who they are. Yeah.
are.
They're from Ottawa.
Oh, they do.
Yeah.
We know they have no databases.
No, they don't do databases. They do files.
They don't
Yeah.
do databases.
Yeah. Which is what these guys only do databases, no files. They do.
I'm sure it's.
I know you've got everything.
We find it.
I'm sure. And the gentleman in the back, he doesn't do anything.
I try not.
You try not to.
Because I did a job for a company here in Waltham, Village Cryogenetics. They had an RPO6 at the time, and they had this huge COBOL business. I hate COBOL. Yeah, and they needed to purge this database and fast. They had never deleted a record for 2 million years. It was the dinosaurs the last time they were deleted. So nobody internal wanted to touch it. They said, hire a consultant. So they hired me and said, can you do it? Well, I need to look at the code. And one thing every company is guilty of, they do not document their data.
Imagine that.
How it's structured, laid out, and how it works.
Mhm.
And I've worked for companies where they print out all the source listings and put it in a folder and says, there's a documentation of the system. I
Absolutely.
said, that's a documentation of nothing.
Hmm.
So I sat at this COBOL listing and I just went 3 pages into it and said, screw you, I can't figure this out. There's no way in hell, and I'm not running it. And so I said, what else do you have? And they had it was the only company I've seen a well-documented database. Had simple data, forward and backward pointers and all, no Oracle, no RDB.
Mhm.
And I looked at that and said, wow, this is really cool. So I went and wrote in BASIC a little program that was about 5 pages of paper. And I gave that to the management. It says, this is what will purge your database. And they said, no way in hell. Look at that COBOL listing. That's nothing. That's what you get with COBOL. And they double dared me and says, come in on the weekend. We got a backup of the database. We're going to run it and see if that works. And it had just 2 tightly looped procedures in it. And it was fast, even with an RPO6.
Good old BASIC.
Huh?
Good old BASIC.
Yeah, good old BASIC. BASIC is the life.
Who doesn't love VMS BASIC? Great English.
We come in on the weekend, we run it, and holy crap! The damn thing works. You can go back to the COBOL if you want.
And now we can document that BASIC because we do the same with BASIC. We read it, we spit out C++ and feed it into Doxygen. The trick here is whatever we do here has got to end up in a C framework for Doxygen to process it. And it can be anything as long as we can meta process it to something that looks like C code. Which is,
If it looks like C code,
well, if you take BASIC, we have a BASIC C translator compiler, but I turned that into a C++ because it looks less ugly, and that's good enough. You take BASIC, get it into a C++, run it through Doxygen. But at that point, it knows enough to pick out the calls in. We're interested in calls in, calls out, and the flow. And that really could just be, it doesn't need to have a lot of, if we don't need executable code in there, we just need the calling in and calling out and the name of the subroutines. It's nicer to see the executable code, which we do, but with COBOL, it goes in as comments, Pascal just turns into C++. So you see the real code.
So the other couple of things here is that the process here is the first part. If you do COBOL, okay, the first part will be what we call the filtering, which is actually it's going to run through your COBOL code, and it's going to sort out everything and create the equivalent file with filters and the comments. The database, you only do that once. You don't, unless you're changing your database every week. Okay, if you are, then that's fine. But if you're not, you do it only once. But even then, that's the fast one. Okay. But every time you run this, you just run through the entire code. Okay. You filter it out, and for this thing, it's got, like I said, it's 100 routines and stuff like that. It took about a minute and a half to do all that. So on a bigger system, which we did for the bank in Belgium, that was about a 20-minute job. That was 6 million lines of COBOL code. Okay. It filters it out and creates everything. And then you run Doxygen on it, and Doxygen can go ahead and chug away, depending on what you're doing with it, because there are different levels of it. Sometimes you want to do just first level to make sure that you do everything, especially at the start when you're looking to see if you have all your sources. Okay. So you let Doxygen to go through and say, don't give me graphs, just go ahead and make sure that everything matches and that you've got everything. And at that point, Doxygen will tell you it's missing this file, it's missing this, or not in the file, but it's missing this procedure. That's not in a, that's in a file somewhere. It's missing it. So you need to go look for it. Okay. So once you've got all that squared away and everything is running through, then you can go ahead and say, Doxygen, go ahead and create me my call graphs. Okay. The call graphs take a long time. They will run 20, 30, 40 minutes for that those 6 million lines of code was about 40 minutes. And then after that, we have another little process that does the markup, the coloring, all the stuff that you see there, that's done past Doxygen. Doxygen knows nothing of colors and shapes.
So Doxygen, what you see there is as the web browser.
Yeah.
And it is as a web browser.
Yeah.
That's Doxygen. And of course, it knows about the dependencies. So the thing we had up there, Graph is actually an ancient piece of software written by AT&T that lets you take call graphs and turn them into those boxes. And with the arrows, it's been around for 40 years.
Yeah.
It's an excellent piece of software. It's called DOT, D-O-T. So we end up, without the colors, we end up with those just generic boxes. We then go through the output that DOT has generated to make these call graphs. And knowing that they're databases, we put in meta commands into the .svg files to color them and change their shape. It's very cool what we do, I must say. I mean, I wish I could say we had something to do with Doxygen, which is the clever part.
Yeah.
Or DOT, which is, we don't. But
It's pre and post.
But it's the processing. Yeah,
I mean, but we make it useful because at that point for databases, and we could do the same thing for tables, for files. We could do the same thing and even change the shape of the file and things like that. So those are all things that you can do. So we do pre-processing before Doxygen and post-processing after Doxygen has done everything to make it look nice. And so that one, an entire run to go from beginning of nothing is there to have everything produced with the colors and everything for that customer takes about 55 minutes. But you don't need to run it every day, but you can whenever you want. And also the big thing is that people, they write code, they make changes and everything, and they never go back to change the documentation. So you can go ahead and redocument it all the time, whenever you want.
16 million lines code, it probably take an hour to generate this, I'm guessing. She's not awful.
And that's on a smaller Linux box. If you have a bigger one, it's going to be a lot faster. Yeah. Because that one is really CPU intensive at this point. Okay.
Well, it was supposed to be this year, it's going to be. He said, no. It's useful because he's handing it over to our short development partner.
Yeah.
Wow.
They've been doing the development for a couple of years, so they know the application, but not his level. There's things that we touched for a while, they didn't get before. I think some easy way to navigate through the whole page.
Mm-hmm.
And equally, this can be used by someone who doesn't necessarily know how to read source code.
Yeah.
They can just put a bunch of listings and structure.
And it's so useful for us. This is not a session where we're talking about migration and stuff, but we have the same problem where we have people assigned to us that retire, that have medical issues, and we needed a way of saying, well, we're on our own now. We're just on our own. And so, yeah, and this has helped us so many times to go in and say, okay, we've got this bug somewhere in the migration. What is it? And what happened? And where do we go?
Yeah.
And I guess the other side is the migration. So,
yeah,
this is a tool to help look at what's the need.
Yes. Absolutely.
Yeah.
Yeah.
And it will detect dead code, won't it?
I don't see how.
No, it knows this. No, if something's not called.
No, Doxygen will know. Well, Doxygen will tell you that these things are not used. Yes, they're not referenced. I'm sorry. What you meant by dead code is this part is just bypassing, never going through it. Yeah. Yeah, it's standalone. Yeah. But it will complain bitterly if it's looking for something that it's not finding. It's going to let you know, and that's critical because you need to find that. Yeah.
It'll come in the executable list. It'll have a program thing by it. So we'll pick that up.
Yeah.
But if it's subroutine and that subroutine is never called, then and that's like it gets to prune it. You get to see, okay, well, of course, if you trust this, which I pretty much do, you can always go back and of course do the old search.
Yeah.
Star just to double check.
Of course.
Well, I certainly wouldn't want to delete a piece of code without at least a search on it.
I think the picture said they don't need it.
Sector7 said you don't need this code.
Very good. Any other questions?
Oh, Pascal, guys. Of course, you've seen the C++.
I have one question, but it's probably not this.
Okay. We can discuss it. Yeah.
Oh, yeah, well, we can talk about that offline.
Yeah. You're right. It's not for this room.
$12, $15, don't remember how much it was. It was cheap. But
No, it actually, they're different models on these.
didn't think about that. $15 per line, that'll work. 16 million lines of code, $15 a line.
But the thing is that at the end of the day, when this is all running and everything, it's on your system. And you can run it as often as you want. You turn the crank and just go.
Oh yeah, it's not a Sector7 thing where we have to take any code. We just give you the tool, and then fix it as you need it.
Okay. Very good. Thank you.